Right, so today we are going to be working on just adding our Bayes theorem into our Excel journals. So if you don't have the most up-to-date Excel journal file, when you go to your home button, you can see it right here, and you're gonna find where it says Excel formula book. If you have one that says Bayes theorem add, just download it, and then when you add it into your Excel formula book, the one that you have saved to hopefully your drive somewhere, that you are just going to copy and paste it into a new sheet somewhere in there and just title the sheet as Bayes theorem. That's what we're going to be working on today. All right, so it says example one, lie detector test. So make sure if you haven't seen that lecture video already on this lie detector test, that you've actually already gone and filled out the written notes portion, and then we're gonna do it again with example two, just with your Excel sheet. So we already know your outcome, which is awesome. So we can actually make it a little bit easier to work towards. So, and it says first go to Canvas, so exactly what we just talked about. Now it says for example, a Bayes theorem helps us calculate conditional probabilities and update the results to be given at the end, provided new information comes to light. So, for example, it can help a weather forecaster update their predictions based on new patterns formulating. So, the prior belief, if we're some weather forecaster, is that based on previous data, there is perhaps a 50% chance of rain in tomorrow's forecast. Now, however, when you go into work and you see a new observation pop up, a weather model predicts that a high pressure system is moving in. Therefore, it's going to lead to clear skies. So it's going to just push off all of the rain clouds that we thought were going to be rolling in, and instead it's going to be a little bit clearer sky. So with that new information, we now have to update your probability based on what we had before. So using Bayes' theorem, the meteorologist can recalculate your probability of rain based on the new information. So keep in mind, whether or not it's going to rain, right? We've just calculated. We said there's a 50% chance. So such that there's the new high pressure system coming in and potentially lowering your likelihood of rain. Now, of course, these examples can go on and on, but this is like the most realistic one that I think you can kind of wrap your head around based on what Bayes' theorem can do for us. Now, for our example, we're going to be using L and T to talk about kind of our system to formulate your probability for Bayes' theorem. It says, using example one in your guided notes, we can do the same with determining the likelihood that an individual was in fact lying when the system's test caught her. So we were given information on the following. So based on your problem, we already figured these two out given our guided notes. So here in B3, we can type in equals 1 over 200, or we can type in 0.005. And again, in B5 down here, where it says the test does not think you're lying. So you've passed, even though you are. So this is where they missed us, right? We got away. Then in B6, the test still thinks we're lying even though we're not. That is a 20% chance. So this is like the worst case scenario. Now, in B4, so over here, B4, find the probability that we are not lying. And it says just use cell B3. Well, these two, in fact, are opposites. So if we're not lying, right, we take 100% and we throw 1 minus the probability that you were, in fact, lying. Therefore, we get 0.995. And again, we now get to see your opposite counterparts. Find that we are lying, and then the test caught us. So that would be here, which is the, in fact, opposite of this one. So equals 1 minus this one. Again, you should be noticing that these values we have seen in your previous guided notes. And lastly, in D6, find that the likelihood of us not lying and then not getting a negative test result. So we didn't get caught. Well, obviously we didn't lie, therefore we didn't get caught. So subtracting one from the other. And you can see the very slight differences in these alterations. We're not lying, but the test caught us, the test didn't, and vice versa. Now, we did talk about this end result here. So it says using your knowledge of the decision tree and by tracking the end results of each is that we calculate the probability, and this one says A and B is the probability of B times the probability, given that we are doing B first, that such that A has happened. So for us, in order to find uh, the probability that we lied and got caught, right, is really the condition that A, we're lying, and then multiplying it by B, we ended up, um, where am I? Over here, where we lied about it, but we still got caught. And again, that says that over here, B3 times D5, and we have that right here. Now we can do it again. The probability that we're lying, so we're lying, uh, times the probability that we lied, but we did not in fact get caught. That would be right here. We lied, but we didn't get caught right here. And again, it says B5. Oops. Yes, I accept that correction. There we go. And again, we should be seeing these percentages all over again from your notes. So if those are looking similar, that's why. So in this case, we are not lying. And the test, though, they think that we're lying. So this is your false positive. So first off, we need to grab the probability that we're lying times the probability that we are not lying, but the test still thinks that we are lying. And the last scenario is that we're not lying here. And we're not lying, but the test also knows that we're not lying. So times this one right here. So you should have all of those coming up again. So from here, let's follow here. As seen on our decision tree, there's no way to calculate the total probability of the test showing all positive we lied or all negatives we didn't lie here. Now, this is the one thing we didn't actually get to calculate previously. I did mention it, but I don't think I was as clear as I could have been. But when we want to tally up all of those that in fact we were testing positive or we were testing negative, right, that is just coming from this t here, which is the sum of these values here. The probability that you lied and got caught versus you didn't lie. You lied and got caught, so you tested positive, versus you didn't lie and you still tested positive. So for us, when we want to test positive, we're going to add the probability of each instance where your t tested positive. And we get to add these scenarios together. Whether or not we lied didn't matter, but the test truly believes that we are lying. And again, we can do it again with those test results that came out negative. It does not believe that we lied. Now, these can be your denominator. So if instead of multiplying, which we had from previously, these two values, if we didn't want that, notice that we have your probability t here, probability t, that is in fact referring to this value. So when we're trying to figure out the probability that the test thinks we're lying, given that we are lying, we could say, okay, well, instead of taking this formula right here, it says equals F3, that is that we are in fact lying, which F3, that's B3, F3, that happening together, divided by, one of these equations says, okay, well, we're going to take the same number and add it to F5, F5 being right here. Again, an instance where we tested positive. We could also do it again. Instead of dividing it by those values, we can just divide it by the total times that your test has come out negative. And there you go. So either one of those formulas is perfectly fine. I might show you that both of them work right next to each other. So you have this one divided by, get that, plus this one right here. And again, equals this one divided by that one right there. There you go. Just different formulas, just whether or not you use the sum. Now this is an extra one. It says, can you determine the probability of a false positive? That is, an individual tested positive for lying, even though that the individual was in fact not lying. Place your response in B10. So that would be right here. Now let's move on to example 2. So snowing and glaciers, Bayes theorem. So it says, It snows in Greenland on an average of once every 25 days, and when it does, glaciers have a 20% chance of growing. When it does not snow in Greenland, glaciers have only a 4% chance of growing. That is the probability that it is snowing in Greenland when the glaciers are growing. So use the above example, so use what we've learned from above to kind of fill in our segments. So they have already given us an insight onto what is being provided. We know that once in every 25 days it's going to be snowing. We also have a 20% chance that when it snows, so when it's snowing, that your glacier is going to be growing. So where is that? Right here. There we go. When it's snowing and it's growing. That we said that is a 20% chance here. And lastly, glaciers only have a 4% chance of glowing when growing, not glowing, but it does not snow. So that is ours right here. So it's not snowing, but your glaciers are still growing. So that is a 4% chance. There you go. Now notice that the remainder is blacked out. So that is the information that you need to find. So see if you can pause the video and at least fill out these few here, right there, and these ones based on what we had done previously. So the probability of not snowing, we have equals 1 minus its opposite counterpart. And notice that these two, in fact, are opposites. It's snowing, it's growing, it's not growing. So equals 1 minus this one right here. And this one, it's not snowing, growing and not growing. So again, these would be opposite counterparts, 1 minus that one. And lastly, you have these four here, right? If it's snowing and growing. So first off, we need your snowing times, and now we need snow and grow happening together here. So here is it's snowing times it's snowing and not growing. So right here, snowing and not growing equals it's not snowing, so this one, times it's snowing and not growing. So it's snowing and not growing right here. Oh, so sorry, not snowing. I want to make sure I have the right highlighted. Therefore, it's this one, B23. So notice that or not snowing here. Therefore, this one cannot be snowing, but it's still growing to match this one. Is equal to it's not snowing times it's not growing. Meanwhile, it's not snowing. There we go. I want to make sure that all of those are, in fact, correct. Snowing, not growing. Love that one. That one looks good. That one looks good. That one looks good. And I believe all of those numbers came up earlier. Perfect. All right. So now let's figure out all of the times that it is, in fact, growing. That is right here. And then again, right here. So whether or not it's snowing is changing. Lastly, if it's not growing, that would be these two values here of not snowing right there. Now, when we are trying to figure out, right, we are trying to figure out what is the probability that it is snowing in Greenland when the glaciers are growing. So right now the glaciers are growing and we want to figure out, okay, what are the chances that it's now snowing? So equals, right? So we want to figure out all of the times that it's snowing. So that would be S and G right here. So snowing and growing divided by snowing and growing plus, what is it? Snowing, not snowing, but still growing. Again, we don't care if it's not snowing here other than the fact that we still want it to grow. And there we see your 17%. We can also do it one more time with the probability of them happening together divided by the probability that it's just growing no matter what. And again, you can see that. Now you do have an extra. It says determine the probability that it's snowing in Greenland when the glaciers are not growing. Place your answer in B27. So there you have it. These ones are just kind of extras. And hopefully that gives you kind of a good insight as to how we can set this up, just as far as the formula goes itself. And again, as far as just why we put it into place with these counterparts. All right, that is your Bayes theorem. As my battery starts to run low, this is a good time to end. There is an optional at least for some of us, it might be an optional lab just on Bayes' theorem itself, kind of setting it up as we did here. And then we might also end up working on um, uh, a decision tree on Excel as well.